Hello, welcome to your presentation to track of research and development, a global view. South Korea is the country where all IP-based ATSC 3.0 terrestrial broadcasting since 2017 and the commercial 5G-based mobile broadband since 2019 services are commercialized. Broadcasting and broadband technologies have unique pros and cons, such as coverage, quality of services, cost, etc. So that Convergência often can offer new services, scalable 8K UATD, seamless switching in a device, broadcasting offload, etc. Today, we have an international expert, Dr. Sung-Ik Park, the project leader of Media Broadcasting Research Section of Electronics and Telecommunication Research Institute, ETRI, in South Korea, who will present their researches for the convergence of ATSC 3.0 and 5G and BMS in South Korea.
Hello everyone, I am Sung-Ik Park from ETRI, South Korea, and I'm leading several next generation terrestrial TV research projects in ETRI. Before starting my presentation, I hope everyone stays healthy in this pandemic situation. In my presentation, I will talk about convergence of ATSC 3.0 and 5G in South Korea. Content of my presentation is as follows. Firstly, ATSC 3.0 and 5G rollout status in South Korea will be briefly introduced. Secondly, convergence concept of ATSC 3.0 and 5G in South Korea will be explained. Thirdly, several convergence scenarios considered in South Korea, such as scalable 8K UHD for better quality, seamless switch in a device for coverage extension, broadcasting offload for reducing network congestion will be discussed. New generation of terrestrial digital TV, as known as ATSC 3.0, was officially launched in May 2017 at Seoul metropolitan area, and its primary goal is to provide 4K UHD content in fixed reception environment and HD content in mobile environment. In December 2017, this new broadcasting was extended to other major cities and will be nationwide by 2021. For ATSC 3.0 based new broadcasting, Korea government temporarily assigned some frequencies in 700 MHz area, and this new broadcasting will be simulcasting with existing ATSC 1.0 based HD service by 2027. After shutdown of ATSC 1.0 based HD service, probably after 2027, there will be frequency rearrangement among terrestrial broadcasters. Furthermore, during 2018 Korea Winter Olympic, ATSC 3.0 based broadcasting successfully demonstrated simultaneous transmission and reception of 4K UHD and mobile Full HD service in single 1 RF channel. Similarly, with South Korea also officially launched the world's first commercial 5G service in April 2019 at Seoul metropolitan area and other major cities. After just 69 days, 1 million 5G subscribers were recorded. Within next 2 or 3 years, the perfect nationwide coverage will likely be constructed at a similar level to the 4G LTE network. For this commercial 5G service, Korea completed the spectrum auction in June 2018 around 280 MHz bandwidth at 3.5 GHz frequency area and 2.4 GHz bandwidth at 28 GHz frequency band area. As you know, broadcasting and broadband have their unique pros and cons. In case of ATSC 3.0 based terrestrial broadcasting, it is free of charge and based on the high power, high tower, so it provides large coverage, much larger coverage than any other network. Furthermore, it guarantees quality of service regardless of number of viewers. However, it had limited capacity due to the narrow bandwidth and also it had limited indoor, underground, mobile reception performance. On the other hand, in case of a 5G-based mobile broadband, it is a payment service and based on the low power, low tower, so it provides relatively small coverage. Furthermore, its quality of service highly depends on the number of users at the cell coverage. However, it has a high capacity due to the broadband compared to the broadcasting, and also it provides easy indoor, underground, mobile reception because it has a very dense, low power, low tower network. So, if we converge broadcasting and broadband networks efficiently, we can reduce mobile service payment. We can provide high quality and personalized service regardless of the number of users. We can also provide anytime, anywhere, seamless multimedia services. Recently, ETRI started a new government research project on convergence of ATSC 3.0 and 5G. Currently, Samsung, LG, terrestrial broadcasters, mobile network operators, and equipment vendors joined this project. And we all are developing basic concept of convergence and some killer applications. This figure shows the basic concept to efficiently converge broadcasting and broadband network. Actually, we are considering two types of convergence. First is physical layer convergence between terrestrial high power, high tower and mobile broadband low power, low tower systems. And ATSC 3.0 can easily integrate other new standards by using the bootstrap. So we are considering time division multiplexing based physical layer convergence of ATSC 3.0 and 5G MBMS systems. Second is IP layer convergence. I don't want to dive into too much details about the IP, but I want to emphasize that ATSC 3.0 is the world's first all IP-based terrestrial broadcasting system, so it can be easily converged with 4G, 5G, Wi-Fi, or any other IP-based system. By converging to independent terrestrial broadcasting and mobile broadband networks, we can provide free-to-air services as much time and many devices as possible. Furthermore, broadcasting service can lead to a variety of terminals, especially from smartphones to the large screen TVs. Eventually, new monetization is possible through the convergence-based anytime, anywhere bidirectional services. As mentioned in the previous slide, we are developing two types of convergence, physical layer and IP layer. For physical layer convergence, we are developing high power, high tower based converged transmitter, which can support both ATSC 3.0 and 5G MBMS standards. Two independent ATSC 3.0 and 5G MBMS signals are time division in a single RF channel and then transmitted from the same tower to the fixed TV and various mobile terminals. This type of physical layer convergence guarantees backward compatibility with existing ATSC 3.0 TVs and makes it possible for 5G terminal to receive broadcasting content. For IP layer convergence, as I said, all IP-based ATSC 3.0 can converge with any kind of IP network. So, free of charge content are delivered through a high power, high tower based large coverage broadcasting network. Additional data, for example, kind of metadata, is delivered through payment-based broadband network. By combining data delivered by broadcasting and broadband networks, we can provide enhanced service like better quality or better coverage. There will be several killer applications for this convergence, but I want to introduce three popular items. First is scalable 8K UHD. Korea is considering efficient 8K UHD distribution within existing ATSC 3.0 ready TVs. As I already mentioned, Korea started commercial terrestrial 4K UHD service, so we need to find the 8K UHD content distribution in backward compatible way with the existing ATSC point LED TVs. For this scenario, we are considering layered video encoding, as known as scalable HEVC. 8K content is encoded to the base layer containing 4K UHD content and enhancement layer, which has metadata to enhance the 4K UHD into the 8K UHD video. This layered video is distributed through broadcasting and broadband network. 4K UHD base layer is transmitted through terrestrial ATSC point transmitter, and so the broadcaster only user can watch 4K UHD content, which is free of charge. But if BC broadcasting and broadband links are both available, user can get 8K UHD content for the same content. Last 2 years, ETRI has successfully demonstrated this concept, but we used 4K UHD, which was consists of base layer HD and combined UHD. So we want to extend this concept to the 8K UHD. Second is seamless switch in a device. IP-based ATSC point transmission allows easy convergence with any kind of IP-based broadband network. High-power, high-tower-based ATSC point is free of charge and also relatively large coverage compared to the mobile broadband, so it takes dominant consumption of video traffic. If there is not enough signal field strength for broadcasting reception, device switch to the IP-based broadband network. Here, IP-based broadband network can be cooperated for coverage extension, especially in deep indoor or mobile, and also makes interactive service through the unicast is possible. In this scenario, seamless switching between different networks should be guaranteed, and viewers should not be aware of such a network change. Last 2 years, ETRI also has successfully demonstrated this seamless switch in a device, but we used ATSC 3.0 and 4G LTE network. So we want to extend this concept to the 5G and Wi-Fi and other IP-based broadband networks. Third scenario is the broadcasting offloading to reduce network congestion of mobile broadband. Service traffic is continuously monitored at the network level, and then popularly requested content such as live sports or news are uploaded into terrestrial broadcast delivery. Concept is quite simple, but I think it makes it possible for terrestrial broadcaster to have new monetization. This is the end of my talk. Thank you so much for hearing my talk.
Dr. Songik, thank you for your time to share your researches with us. Thank you for watching your presentation. If you have any question for our speaker, contact him through his email address. I hope to see you in the next episode of Research and Development, a Global View.